Let's multiply by 3 or 6. So I like how Khan Academy has this broken up. Like, we're specifically multiplying by one number because at this stage in the game, if I'm multiplying any number by 6, I can always get the answer by counting by 3s, right? Or just by doing 3 plus 3 plus 3 plus 3 the other however many times. You can use your fingers, you can do whatever. And I like that this is a really nice, gentle way of introducing this stuff so that you have backup strategies in case the new strategies don't work. And that's so important. You should always be able to fall back on previous knowledge if the stuff that you're currently learning isn't quite meshing. You should always be able to go back to what you already knew and solve the problem anyway. And that's on the educators like me to make sure you've got those skills. 2 times 3 is 6. And again, I like this idea of jumping on the number line instead of groups of objects. I like all of the different ways that we're talking about this. Arrays, areas, skipping like this, counting by counting by 5s and 10s. All of that stuff it's all multiplication and it's all related. So it really makes me happy to see Khan Academy doing all of this different kinds of concepts all in one go. 3 times 6 is 18. 9 times 3 is 27. Yes, I am aware of the multiply by 9 trick where you use your knuckles. It takes too long in my opinion, but it definitely works for a lot of folks. 3 times 7 is 21. 4 times 3 is 12. If you look really hard at that image, little phantom squares will begin to appear in the corners. Ow, my eyes. Moving on. 5 times 3. Actually, this is a perfect example because I just made cookies for my family for Christmas, for the holidays. And I wanted to know how many cookies did I want to give to each of my family members. I settled on 4 because 4 is a reasonably generous number of cookies. And then the question became, how many of my family members can I feed with my recipe? And I did multiplication and division, and I applied it to real life to determine how many ingredients I had to pick up. And that way I didn't have to go back to the store multiple times, and I didn't buy so much that I wasted my money. So, real life, right here, cookie math. 5 times 3 is 15. Who says that you don't learn useful things in elementary school math? 6 times 3 is 18. We're talking about cookie maintenance here. That's multiplying by 3. Now we multiply by 6. Multiplying by 6 is harder than multiplying by 3 because it's harder to count by 6s than by 3s. It really is. Multiplying 9 times 6, there are a couple of ways that you can do this, all right? I'm going to give a couple more of my little mental math tricks here. So if I'm doing 9 times 6, okay, there are a couple of ways. One thing you could do is you could do 10 times 6, which is 60, and then just subtract off the 1 6 too many that you added, right? It would be 6 times 10 is 60, minus 6 is 54. That is one way that you could do it. And God, I wish I could write down on my whiteboard. I'm going to complain about this all stream. The way I also do it is, for me, I look at the second number, I lower it by 1 to get my tens place, and then I know that the digits of a number that is a multiple of 9 always add up to 9, so I know that it's a 4 because 5 plus 4 is 9. And that is a thing that I will do a video on at some point. Why is it that the digits of a number that is a multiple of 9, any multiple of 9, if you add all the digits together, you will get another number that is a multiple of 9. And that's just a pattern that pops up that is easily explainable, but seems really weird at first. 54. This is also where the knuckle trick comes from. Because when you remove one of your knuckles, then there are 9 left, so the 2 digits will always add up to 9. 6 times 1, anything times itself. Anything times 1 is itself. 1 times 6, also, still just 6. 6 times 7, now this is one that a lot of folks get wrong. I see a lot of 48 here. And I don't know why. It's something in our collective mathematical subconscious. For some reason, 7 times 6, a lot of people have a hard time with that. When you are multiplying by 6, what I tend to do, and again, this is just what works for me, what I tend to do is I try to multiply by 2 and then 3, or the other way around. Doesn't matter which order, but I want to multiply by 2 and I want to multiply by 3. So if I'm doing 7 times 6, I could do 7 times 3 is 21. 21 times 2 is 42. All right? Because 6 is 3 times 2, you can break that up in any way that you want. And in the next stream, once I'm sure I have my whiteboard up and running again, I will demonstrate this much more visually. 10 times 6, just add a 0. 7 times 6, we just said, is 42. Repeated reasoning, right? One of those big Common Core standards, one of those big practices is look for repeated reasoning. If you already solved 7 times 6 and you just know that it's 42, great. So long as you can also understand what this visual is trying to tell you, so long as you can understand that, it's totally okay to just memorize the times table and go. It's totally fine. Just be able to put the thought process into words if you have to. 3 times 6 is 18. And it even tells us right there. Boom, 18. That's multiplying by 6. We're going to move on to multiplying by 3 and 6. 2 times 3 is 6. We just described that in great detail very recently. 6 times 7, again, we already did this problem. And that's the thing. One of the reasons why this is going to end up eventually mostly being a matter of memorization is because there's only so many combinations of single-digit numbers. 6 times 3 is 18. There's only so many combinations of single-digit numbers that you can multiply together. Right? So you're going to end up seeing the same problems over and over and over again and over again because there just aren't that many to be had. 9 times 6, as we said before, is 54. 9 times 3 is 27. Again, either by using the knuckle trick or whatever, I see 9 times 3, and I know that I'm going to take away 1 from this bottom number to make 2, and that's going to be the tens digit. And then I know that the 2 digits had to add up to 9, so the answer is 27. 6 times 2 is 12. 3 times 10 is 30. Just add a 0. 8 times 6. Now that's our 48. That's our 48. And again, there are lots of ways that you can get there if you don't memorize off the top of your head that it's 48. 8 times 3 is 24. Times 2 is 48. That is one way you could go about it. And 8 times 3, hey, it's 24, like we just said. And 6 times 6 is 36. For some reason, people memorize the square numbers pretty easily. I think it's a good thing. I just don't understand it. All right, so we've done lots of multiplying, so that's what quiz 2 is going to be about. Let's burn our way through it. 5 times 9 is 45. 10 times 7, just add a 0. 6 times 3 is 18. Again, just want to reinforce really quick. You could go 3, 6, 9, 12, 15, 18, or you could count by 6s if that's something that you can do. I don't know that I'd be able to count by 6s very far, very fast. 3 times 10, just add a 0. But no typos this time, please. 3 times 7 is 21. And then finally, 5 times 8 is 40. 5, 10, 15, 20, 25, 30, 35, 40. Counting by 5s for some reason is really easy. Maybe because it's a nice, steady, easy cadence and pattern. I don't know. That's quiz 2. Fantastic. Now, The distributive property is something that I think I'm really going to need my whiteboard for. Thankfully, I have quite a few videos already in the pipe for my YouTube channel. So I think what I'm going to do is I am going to leave us at 50% mastered here on multiplication, one-digit multiplication. That's the unit that we're in. We're at 50%. I think I'm going to leave it there. And I'm going to say thank you so very, very much for joining me on this admittedly short stream, but I'm having a little bit of technical difficulties. If I can't use my whiteboard, then it kind of cripples my ability to engage with more visual learners, and I feel like that's not fair. The only reason I did this is because most of my one-digit multiplication knowledge is basically memorization, and I know that any more complex thought processes that I want to write out, I can do next week when we start talking about the distributive property, which is so very, very, very important that I will be probably devoting quite a bit of time to that topic and doing a lot of examples. For the time being, thank you so very much once again for watching. You can find me here on Twitch or on Twitter at Math Demigod. You can find me on Instagram at Professor_Cunningham, and you can find the VODs of this very stream from kindergarten all the way up on my YouTube channel, which you can find at professor-cunningham.com. Please do subscribe. I only have a few dozen subscribers on each of my YouTube channels, and you don't get into the algorithm until people start subscribing and start watching. So if you can find it in your heart to go and hit that subscribe button, I would really, really appreciate it. Thank you so very much for watching once again. I will see you next week. Have a good Monday.